In this video, we're going to add a copy constructor to our string class. So we can add it here to the list of existing constructor, and we can say that this is a copy constructor, and its signature is this string, and then and here is just another string passed by constant reference, and we'll call it another, right? So it's another string. So this copy constructor is invoked when we do things like this, when we have an existing string, which is another string, and we create this object for which this copy constructor is invoked. And we're concerned that this object, this another object, may have already allocated memory dynamically, and we want to be able to basically create a deep copy of that other object so that we have our own memory to manage as opposed to pointing to previously allocated memory. So let's take care of this. I'm going to copy this from my header file over to the implementation file, and this is the list of my constructors at the top of the source file. So just copy and paste this here. Once again, this is the same syntax, right? Make sure that we get rid of this semicolon, and we're going to continue to use our initializer list to populate our objects with those things. So string view can be constructed from another string view to begin with, and the pointer here can be initialized to a null pointer. So this is the beginning of our initialization. So we've constructed our string view object inside the string, and we also have our pointer to string left as null. So then we can say that if we know that another object's PSTR is not null, right? So it does not equal null pointer. Or you can just do it this way. Anything that's non-zero is true in C++. So we can leave it like this, or we can just do it explicitly. Let's do it explicitly right now, which kind of highlights the idea, right? So what we need to do is we have to make a deep copy of another string PSTR, because it's being dynamically allocated. So we can do it in a similar manner as we did before. So we can say PSTR of the object that we're trying to construct equals new character block, and the length of that character block should be another object length. And of course we also need to add 1 for reserving space for zero terminating character at the end of this block of characters. Then we will use our function string copy, and this will be our destination. So this will be copying into our own PSTR from another PSTR, and string copy automatically appends zero terminating character at the end of the copying. So this should take care of making the actual block of memory that will contain the same characters. And finally, we have to update our string view with the newly allocated PSTR. I think that's what we need to do. So let's see if this takes care of our issue with copying when we already have it. So basically, in this implementation, what I'm expecting to happen is that this hello greeting was allocated by concatenate result, which contains a pointer to dynamically allocated string. And now part of this initialization, or on this line basically, a copy constructor will be invoked. The copy constructor will just assume at the beginning in its initializer list that another object does not have a dynamically allocated string of any kind. Then it can just make a copy of the existing string view. If it's not the case, then we look at another PSTR that it's dynamically allocated string. Then of course what we're going to do is create this new block of character for this object and string copy, which will copy everything from the old string to the new one, and also update the string view so that the string view encapsulated here should be looking at this these characters. So basically this should finalize right here the creation of new object with properly allocated dynamic string. So let's take a look at the results and see if we can now no longer have an issue with this conflict between the two objects when we make a copy like this. Let's first build. Okay, so it builds okay, so the syntax seems to be fine for this copy constructor. Of course, we can now step into this line and we should observe that our constructor is being invoked. So why don't we do that? Debug, start debugging. So we step over this line, F10, I press F10, we print the greeting, and then I press F11 to observe the execution of this copy constructor. And here we go, right? So we already here, we step, I'll press F10 to step, so it steps through initialization, and you see that we did step into this if statement because, of course, this hello greeting has a non-null pointer PSTR. So we step over this, we make a copy, and once again we can just go to our debug windows and display our local variables. So right here we have the this, okay, which contains hello world, and another which contains hello world. And if you look carefully at these pointers, the actual values of these pointers are different. So our new worked pretty well. So far this looks good, and I'll just step over the final line over here. And in general, if you're satisfied with the view in debug mode, you can always can go to debug menu and say step out, which means that it will take you back to the caller. So in my case, stepping out of this constructor took me to this line, and now I press F10, and I'll just press F5 or debug continue. And if you recall, when we had this conflict of deallocation, shallow copy twice, now it should be gone. So I press F5 and everything exits nicely without the exception that was visible in the previous situation. So this copy constructor really makes our object much safer to use, and this is something that is important about copy constructors. So default copy constructor always given, but it does this binary copy, which not necessarily produces satisfactory results. In general, if you start using pointers in your classes, just remember that it is extremely high probability that you need to start writing your own copy constructors to control the semantics of copying your objects, because in my case, as you can see, what we did over here was that I recognized that I need to create a deep copy of another string. Otherwise, there is no way to properly manage removal of dynamically allocated resources. In my sort of like path to developing this class, I want each instance, each object of this type, string, if somehow it was linked to dynamically allocated string, I just want to make sure that it completely owns this resource, right? So this owns the resource, and its destructor is responsible right here. The destructor of this object is responsible for deleting this resource and returning it back to the operating system.